Hello. Yeah, so let's start. Okay, we have six problems. So while browsing Reddit, you came across a post containing the codes to the source. You have the source, but the source is encrypted. The post is also fake code, so hide the amount of sublinks. You've read them, figure out the source. Okay, you can do the following operation in number of times. Usually Latin alphabet replaces all its occurrence with either 0 or 1. Check whether it's possible to decode if you print. Okay, all the binary strings 0 and 1, no adjacent bits are equal. No adjacent bits are equal. Okay, for example, while are not input cases, so basically either 0 check is possible to decode the code. Yes, check for sample test cases. Okay, I don't really understand the question. You can let 0 1 alternatively, A B in second case also. A double B, basically you have to check the alternate characters are not matching. So it's just that the alternate characters should not match, right? So when you replace it with choose any Latin and replace it, all its occurrence 0. So okay, so the alternate characters should not match. That's all. So let's take let's say it's not matching, and for all the indices, so for n you can just do okay and is equals to s of I is not equal to s of I plus 1. You do not want to overflow, so you do that, and you can just print yes or no based on it, right? So n should define as stop length. That should do okay 10. So whatever was 5 plus 1. Okay, we have to read and should work now. Yes, it worked. So 6 plus 20, submit it. And after years of searching for the treasure, you finally found it. It's just one to the treasure. She I don't write stories. The loot is split into n piles. Each pile is AI pieces of according to the inscription. If you want to take one of the item, you must take 2 pieces from it. So I minus 1, I minus 2. Wait, say 2 and 1 piece from its neighbors. So that is you take 2 from it and 1 from the neighbors. If at the end every pile is not empty, you die. If you can get okay. Any pile is not empty. If you cannot get the loot by following the rule, you die. You leave a part, you die. Okay, can you take all the loot and survive? So you have to take all the loot. So 1 to 1 you can take it. Okay, you take 2 from here, 1 and 1 from each here. So 1 3 5 2 you can take it as you take 2 from here and 1 from each, right? So basically you cannot pick from the first index, right, and the last index, so that has to be satisfied already, right? So I think you can keep on satisfying the first one, right? So what you can do is I hope my screen is visible. Yeah, so for B you start from the first index, right? You start from the first index, and first 0th index is what you cannot pick, so you start from the first, right? And the first index should always satisfy this. So basically if there's k loot, you subtract k from here and you subtract 2 into k from here, and at any point it shouldn't be negative, right? And you keep on doing it until the also if you subtract k 2k here, you subtract k here as well, right? So you keep on doing until the n minus 2th index, right? And that shouldn't be and when you do that here, from here everything should just result in 0, right? So again I think doing it linearly is enough, right? So when I implement it will be easier to understand, right? Okay, this did not pass. In operation change and 0. It's possible to decode print yes, otherwise it print no. Hmm. The source is actually an alternating binary string. Okay. So you have to make sure that it's alternating as well, instead of just being not equal. Right. So P. So I think you can just do the mapping check then. Right. So what you do is you can do map int and not int, let's say char int. Right. So I think what case is failing here is A B C A B C D B is failing because this is 0 1 0 1 0, right? B is getting 0 here and 1 here, so it's not forming alternating string, right? So what you can do is for 0 and jumping 2, so if A of I, let's say if map of A of I, no, instead of let's say 0 is unassigned, right? 1 is 1 and 2 are assigned. Okay, so we make 1 2 alternating. So if map of A of I is 0, right? So let's start with 1, right? If map of let's start this alternating element as 1, so map of S of I is equals to 1, and else if this shouldn't already be, if it is 2, right, you make it false, right? So basically everything here should be 1, right? Same goes for if you start with 1, if it is 0 you make it 2, and if it is 1 it is wrong, right? So that should be enough, right? Again, okay, it's a single equal to, is this worked, and yes, that's now it's correct. So submit this, right? And for the second problem, you can read the array first, right? And from 1 to the second last index, what you should do is A of I minus is equals to 2 times A of I minus 1, right? So you have to nullify that first, and A of I minus 1 is 0, right? And similarly A of I plus 1 is also before nullifying it, actually you subtract the same from A of I plus 1, right? And this will keep on happening, right? These are the 3 steps that you have to do, right? You're subtracting a base, you're trying to make the previous element 0, right? So now what in the end what you have to check is you just print whether A of let's hope the terminated due to timeout, very nice, we'll do that later now. So the size of what is the constraints on size? The size is at least 3, right? So yes no answer is actually n minus 1 should be 0, and A of n minus 2 should also be 0. Close it. Right, so I think this should work. Let's see. meanwhile, let's read the third problem. So, Merlin the Wizard, fascinated by magic potions, can be created using special ingredients. Each ingredient has a power level, and ingredient deemed special if its power can be written as sum of distinct non-negative powers of M. So, for example, M is equals to 3. The ingredient of power level 30 is special because it can be represented as this. Okay, so but the ingredient power level 8 is not. Okay, none of this passed. Okay, I think alright. Okay, there is no it's case sensitive. So I should now pass. Meanwhile, okay, so 8 cannot be represented. There's a power of 3 is what it says. Okay, this passed. So its power, if the power can be written as some distinct non-negative powers of M. So 3 raised to the power 1 plus 3 raised to the power 3. Right, so is it this 3? No, I think you're getting two numbers. You're getting the number that you have to form. For each query, the pth special portion power of level is in ascending order. Output 1 into the pth special portion's power level. Number of queries, each of the next line corresponds to NM and P. pth special ingredients powder. Okay, so so for 3 you can form 1 3 3 plus 1 4 and 3 square. So for 3 the fifth special is 5. So sorry, so fifth special is 10. So for 3 you can first let's say 0th power, first power, second power, third power. So the first element is going to 3 raised to the power 0, it's 1. Another element is going to be 3 raised to the power 1 plus 3 raised to the power 0, that's 3. 1 1 is going to be 4. Similarly 1 0 0 is going to be 3 square 9, and 1 0 1 is going to be 10. So this is the fifth power. So basically you can see this is binary for 5, right? So you can break the number into binary form, right? And you have to add those powers basically, right? But the fact that the number P can go up to 10 raised to the power 9, that means 32 bits. I think it's you can just do it directly iterative, right? So we can read M and P, suppose that was that, right? And I'll use a template for modding. It's called mint, and I believe the mod is 1e9 plus 7. That is supposed to be mod 1, right? So I'll have a mint answer is 0, right? And so we'll split P into binaries, right? And let's use the inbuilt power, but that is that returns a decimal value, so let's just hope it works. Now we'll read P in terms of binary. So P can be up to 32 bits, right? So if the current bit is on, so we check the current bit is on like this, right? So if the ith bit is on, we have to multiply 3 raised to the power I, or m raised to the power I to it, right? So what you do is you add power of m raised to the power I if the ith bit is on in P, right? And I think this solve. Uh, Actually, let's just do for J0I mint D is 0, D plus equals to M, right? Sorry, not plus, so it's a power, so we can keep on multiplying, right? And remember I'm using mod class, so it will automatically take the mods, and in the answer I can just add D, right? And hopefully it works. Yep. So submit this. Alright, we are fifth right now. Okay, this should have been solved. Maybe we should just submit it again. Let's see. It's now snowing, and wants to know the snowflake to bring to like bring to life. To bring it to life, he needs to find the carbon snowflakes, caravan snowflakes. Okay, all snowflakes will be similar to this form. To find, you need to find two parameters of snowflakes, which call x and y. X is y, and number of children of the center, and y is the number of children for the direct children of the center. Okay, y is same for all the direct children. For example, the first diagram of x is equals to 3, y is 3. We give you the list of edges connecting all them, find out x and y and print it. Okay. So I'm assuming x is not equal to y here, which is not. Okay, so let's say x is 3, so you have 3 direct children, and all the direct children of the center has 5 children again. Right, okay, when this was, what's wrong? Map of is a phase 2 as a phase 1. Okay. This was without quotes, without quotes. Okay, they made it case sensitive in the middle of the contest. Yes and no. Let's run the code. Right, let's submit it. So, okay. So you're just given an edge list, and you have to find both x and y. It's terminating to timeout, which it shouldn't actually. So we'll just use an unordered map. No, it should run. Okay, so for this problem, you can. So basically, if you find the degree of all the nodes, okay, so so for the snowflake problem, I believe it's the D problem, right? If you see, the degree. So there will be one node with the degree of what we call as x, and all the other nodes will have degree of y or 0, right? So if you map all the degrees, you are just going to have two unique degrees, right? Okay, this passed again. So what I will do is okay, I'll find all the degrees now, right? So we are given an edge list. Let me see the input type first. So it's n and m nodes and edges. Okay, I don't think we need to construct anything because just reading the degrees is enough. Like, so we'll call degrees of n, right? 0 base, so it's perfect. So for m, you can just read u and v, c in u and v, right? And again, this is an undirected graph, right? Okay, so this will have 1. So everything is going to have 1. So there can exist, okay, so these leaves are going to have a degree of 1, right? I'm not talking about in degree or out degree specifically, any degree, right? This is going to have actually y plus 1 because we are counting this node as well, right? I believe that's number of children that we're talking about in y. Y is the number of children, okay, and x is just x. So we are going to have 3 numbers, which is basically x, y plus 1 and 1. The numbers can collide, and we'll see that we see how to handle that later. So degree of v plus plus, right? Now for out of all the degrees, let's just take the common ones, or actually there's you can actually compress the array. So to compress it, you can just sort it first, right? Sorry, and I have all the macros written. You can just refer my code, right? So if you print the degrees now, you'll see what they are, right? So that's 1, 3, 4 and 1, 3, 6. So understand that 1 can be a lot, right? There's no bound on 1, okay, and 3 and 4, right? So there should be 1 degree, okay, so it can, so this x should just be 1, right? The frequency is 1. Y's frequency can be 1 to whatever number, right? These 1 can be lot more, right? So I'm assuming if you have 3 numbers 1, x and k, you have to find the frequencies as well, right? So instead of doing this, let's just have a map now, right? And let's just do each degree, let's just map it to their count, right? And let's print the map now, right? So 1 is 9, 3 is 1 and 4 is 3. So you can realize that 3 is actually x and 4 is y, but you have to subtract 1, right? Because it's y plus 1. You don't have to consider the back edge, right? So okay, so let's just do a blind guess. So let's say, so you have to print x and y, right? So what I'll do is each x in map, if x dot ss is 1, right? If the second component is 1, I'll just print this, right? So saying this is my x, right? And I'll record or let's say let's just record x, right? Int x is int x, and we are sure that it will be something, right? Let's just take x underscore, so we're not confusing the variable's name. Now you can again go with map, right? And you can say if x dot ss is not equal to 1 and x dot ss, now it can also be that y is 1, right? It can also be that y is 1. Okay, no, it is guaranteed that all inputs of SOAP x and y is greater than 1. So you don't have to worry. So if x dot ss is not equal to 1 and x dot ss is not equal to the x that you've already found, you can actually have that as x and y, right? because if that is not 1 and that is not x, it is supposed to be y. You can just have 3 unique degrees, right? So you can just print x and y now, right? Y you can store, sorry, it's x underscore, right? Sorry, it's x dot ff. Similarly for y, it's also ff. That's the frequency, is the degree. First is the degree, second is the frequency. Okay, we're making some mistake now. If x dot ss is not equal to 1 and x dot ss is not equal to, sorry, here, degree, count is not 1 and it's not equal to the degree, right? Yes, that we found for x. Right, now we can fail. Can we fail in a case? Actually, if x is 3, if the degree of x is 3, y can also be 3, right? Right, by how? Let's take this snowflake, right? If you can see, this is y and the degree is also 3 and even x degree is 3, right? So this will fail in this case. So if they are so if y is minus 1, right? If y is minus 1, basically you just have 2 unique degrees now, right? So y is similar to x in that case, right? It's not similar to x, but it has to be minus 1, right? Because again, you're not counting the back edge, right? So let's see if it passes. Maybe use uninitialized in this function. Why is x uninitialized? No, it will always be initialized, right? I hope this should pass. Okay, might be a corner case, might be 1 or 2 more corner cases. Okay, that you have to go through. Okay, what can be another case? Now they have guaranteed that x and y is greater than 1, right? It's guaranteed that all inputs are valid snowflakes and x and y greater than 1. Right, so okay, so here we'll run into a problem, I think. If the frequency, okay, the frequency of this 3 is now not 1, right? Okay, so actually we can just generalize it. Right, so actually you can print, let's see the size of map first. Right, let's just remove this for now. Right, so size of map is 3. So what happens when size of map is 2? When it is 2, you can just so x becomes, or let's just say each y in map max degree. So you can take the max degree, right? So if y dot ss, so the count, or you can just take the maximum degree out of it, right? Because if the size of map is 2, whatever is the maximum degree, it is what the snowflake is, right? At least the center one, right? So you can start with a negative and you can say x is equals to maximum of x and y dot ff, right? Whatever the maximum degree is. Now x is as x already, right? And y is, you don't have to count the back edge, so it's y minus 1, right? What happens if the size is not 2? Remember, you can just have 3 unique values, right? So in that case, you'll do what we did earlier, actually, right? So in that case, actually I just reuse my own code. Submissions. Right. So for that, you can do the same thing. Right. Let's hope this works. I'm also getting rusty because I have not coded from long while. Right, okay, this passed. Okay, so we are first now. Now, group of n fortresses are lined up in a row and number from one of one certain structural integrity. The ith fortress is the integrity value of h of I. Ramping golem attacks these fortresses m times in a specific sequence. For first it attacks the first fortress, then the last fortress, then again the first, and so forth. Okay, each attack with a golem decreases the integrity of target fortress by 1. When a fortress integrity drops to 0, crumbles and none of substitutes. So there's ceases to be the first or the last. Okay, if all the fortresses crumbles, golem has nothing to attack and stops rampaging. If number is equals to 5, m is equals to 5, 4 and 5, so 4 elements, and m is 5 is well, it's supposed to be m. Fortress m times. Attacks these fortresses m times in a specific sequence. Okay, so the golem attacks first one, the last one, first one, last one. Okay, is for how many fortresses can crumble after golem's rampage? Assuming the constraints are really high, so you cannot linearly compute it. See, so it does 10 to the power 15 attacks. Right, so you have to go on. So okay, so this is a bit implementation heavy problem where you have to if this is k and this is x and y, so if the golem attacks this x times, right, if golem attacks it x times and attacks, it will also attack it if it comes back to it, right. Now it depends on what is greater. Let's say x is greater than y in the current scenario, right. So for it to attack it x times, it has to attack y x minus 1 times. Right, how? Let's say it's 2 and 3. So it attacks it once, twice, it crumbles. Right, and it has just attacked it once, that is 2 minus 1. Right, if it's the other way around, 3, 2, attack it once, twice, thrice, it crumbles, but now it goes on to attacking here. 1 second. So it attacks once, twice, it again goes there, right? Here it attacks once, twice. This actually crumbles, and this also crumbles, so it again goes back here. Right, if both of them are equal, 2, 2, it attacks this once, this twice, it crumbles, this twice, it crumbles, then it comes back here. Right, okay, so you can write a 2-pointer, but it's going to be very spaghetti. Let's find a better way. Okay, how about we change the arrangement? So if it's 27182, right, it is 27182, right. If we can segregate the elements, let's say we read one in forward fashion, so 27182 in forward fashion and 28172 in reverse fashion, right. So at any point of time, let's say this is I and this is j, any point of time is I plus j is double equal to n, right, is the time when is double equal to n or n minus 1. So basically if I reaches here and j reaches here, I is 1, j is 2, 2 plus 1 is 3. So if I plus j plus you add 2 for offset is double equal to n, is where we have to see that okay, we are going to come up on the, we will be coming on the same index now. So so we can now you can see that this is actually the reverse array, right? It's pretty obvious. So what we can do is let's take the minimum, right? So we are always starting with the first. So if we subtract so let's without loss of generality, let's just have that we are always attacking this one first with every element. So we take the minimum element, right, of the first and the second, right, and what we then do is we subtract the first one with, so let's say k is the minimum of both. Let's call it a of pointer 1 and a of pointer 2, where pointer 1 is I and pointer 2 is this j, right, essentially the first and second elements, right. At any point a of pointer 1 should not be equal to a of pointer no, this should not hold, right. So we take the minimum, and actually we'll have to see what is minimum, right. So if let's say a of p1 is less than a of p2, right. So let's take all the cases, right. Let's start with equal because that is most intuitive, right. If both of them are equal, what is going to happen is crumble, hit, 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 hit. This crumbles, right. And you are going to attack this next, right. So if a of p1 is double equal to a of p2, a of p1 will become 0, right. A of p2 is going to become we can write it later, a of p1 is 0 minus equals to, or if they are equal it will just become 1 anyway, right. And remember that this will come up now. Now what I'll do is if I'm reading it as two vectors a and b, I'll swap a and b, right, and I'll swap the pointers as well, right, p1 p2, but the fact that because the first has crumbled, so we'll do p1 plus plus, right. Or essentially you can write it as a of p2 is a of p2 minus a of p1 minus 1, that I know is always going to be 1 because p1 and p2 are equal, but you'll understand later. Now else if a of p1 is less than a of p2, right, so it is something like 3,5, so you attack once, twice, thrice, it gets cut down, and you come here, right. If you see that this is actually equal to this, right, so you can actually write a of p1 is less than equal to, right. And if it's the other way around, now a of p2 is greater, so 3,5, so 1 1 2 2 3 3, this is dead, and you come up here, right. So what happens, a of p1 minus equals to a of p2, right. A of p2 becomes 0. Basically you don't really have to code it, you can just take an answer variable, every time it falls just do answer plus plus, right. Here also you can do answer plus plus, and here p2 is crumbled, right, so you do p2 plus plus, right. And you don't have to swap anything because you're again back to the first element, right. Now the terminating condition is where let's say, right, we don't want them to cross each other, right. So if it is something like 1 1, let's say it's 1 1 1 1 10, so the reverse will be 10 1 1 1 1, right. So by the time you're defeating 10, you are already crossed everything and you have come back here, right, you have come back here, so we do not want this condition. So let's, if this is p2 and this is p1, so in any case p1 plus p2, so if p1 plus p2 is plus 2 is equal to n, right, or if you have defeated it and crossed here actually, so this is 0 1 2 3 4 and this is 0, so even plus 1 is equal to n, so you can basically just break out, right? You can break out and you can see that whatever damage is remaining now, is it enough to break either a of p1 p2, because both of them are the same element. If that is, increment the answer again, right? So it's a bit implementation heavy. Let's try. Right, so we read n and m, right? I'll read the array as well, right? I'll make another array b of n, which is basically b is a, but it is all reversed, right? I take 2 pointers, 0 and both of them will be 0 actually, right? So basically you can just do while p1 plus p2 plus 1 is not equal to n, right? If a of p1 is less than equal to again, I'm not telling you cannot implement it with 2 pointers and a single array, but I feel this will be a bit easier, right? So if a of p1 see here the problem is yeah, they are not the same arrays. Okay, one is b, right? So just give me 1 second. A of p1 is fame p1 is less than equal to b of p2, right? You do b of p2 minus equals to a of p1 minus 1 minus a of p1 minus 1, and you can do let's have an answer variable, right? Just do an answer plus plus and p1 plus plus swap a and b, swap p1 p2. I believe this is what we did. Yes. In the other case you do a of p1 minus equals to, basically for that to go down, minus it with the same value and you don't swap the tempo, right? A of p2 answer plus plus and p2 plus plus, right? Now if a of p1 now when you come out, right? So if p1 plus p2 okay, and you also have to decrement m, right? So fact that if you have to decrement a of p1 minus 1, right? So if m is less than a of p1 minus 1, you break out of the loop, right? Because you do not have so much attacks remaining, enough attacks remaining to break it down, right? Same goes here. So if m is less than a of p2, you can break, right? And m decreases by a of p2. Sorry, this is b. B of p2, b of p2, right? And if a of p1 plus p2, if p1 plus 2 p2 plus 1 is equal to n, this was a initial terminating condition, right? Now they have two conditions. This should not be equal to n and m should be greater than 0, right? And do we need this condition? Actually we don't need it, right? That is applied here itself, right? So okay, let's see now if it is terminated because of this, right? So you can find the minimum value, right? So you take the minimum because that has been attacked in that current tempo, right? So you take the minimum of b of p2 and a of p1 basically, and answer is incremented if m is greater than equal to the minimum, right? And then you can print the answer. Okay, we are getting wrong answer. 4, 5. So let's see what our P2, P1 and P2 values were. Now P1 P2 values in the first case was 2, 1. So 1, 2. Okay, seems a bit wrong. Okay, this is P. Let's just check our variables once again, because we are using a lot of ABs. Right, so P1 is always assigned with A and B is always assigned with P2. That's fine here. Alright, so let's see how this is changing. So print A, let's print P1, P2 first. Then print AB. Sorry, A has been printed, so we just print B. Let's see what is happening. Right, so P1, P2 is 0, 1, and so we are done with the first. Remember that when the first is smaller, we swap the arrays as well, right? So if you see in the first case, the array has been swapped. I'm surprised why is M not decreasing. Okay, because we are decreasing it to -1. Is this an error? Okay, B is decreased with -1, but the number of moves that you made is A of P1 here, and here it requires 2 times this, right? Okay, so I'll explain this first. So when this goes down, understand how many moves we are doing here, right? For 3, 5 to go down, you are attacking it thrice and you're attacking it this twice, right? So the total is 2 into 3 minus 1, right? If it is the other way around, if it's 5, 3, if you are attacking this thrice, you're also attacking this thrice, remember? So it's 2 into 3, right? So that's why it's -1 here, but there it's just 2 times, right? It's 2 times V2. Right, so only 2 buildings are going down. Let's see if this works. It actually passes. So okay, let's see our initial. So what if it's 1, 1, 1, 10? So here we should just be making 3, which is correct. What if we have 50? So we break everything. Right. Let's hope this passes. There might be some error. It's not the most cleanest code. Let's see the leaderboards. Okay, still on top. Okay, everything passed for this. Right, now let's try F. In the magical land, there exists a powerful sorcerer loves playing. Okay, the authors of sorcerers wrote sorcerer strings of symbols. The symbols represent to locus Latin letters. One day, a sorcerer sets a challenge for the inhabitants of the land to find the shortest magical sequence recorded case such that repeated multiple times to form a string of almost identical to the given enchanted string S. Shortest magical sequence, okay, repeated multiple times. However, there is a catch while forming new binary string by repeating K. Okay, string is K. At most, one symbol can differ from the original enchanted string. Townsfolk eager to prove their wit must solve the challenge for multiple enchanted strings present by the sorceress. Sorcerer AZ, okay, can have 2, at most 1 symbol, at most, so you can also not have anything. So here you can have, okay, ACB, BCB, ACB. No, the one thing is that it should be a factor of the length, right? Because you're repeating it, right? So I think you can brute force all the factors. Number is 200,000. I think you can brute force the factors, yes. Again, we'll just try it once, right? So you can have one different, right? So what happens is that if you break the string, right, for the e problem, if you break the string, right, let's say in some parts, and what part you have to break, because that is a factor of the initial multiple, right? So if it's 20, you can break it in 5 and 4 and other numbers as well, right? So I think we are to find the minimum or the maximum. Sequence K, find the shortest magical sequence. Okay, to find the shortest magical sequence that can just differ by a single okay, character. So you know that all of them are of length 5s, right? 5, 4, 20, right? So you can take all the 5 pairs, all the 5 length, and first of all, just let's say you map everything, right? Let's say you map all these strings. Now what should happen is only you should have 3 strings with a frequency, or you should have a string with a frequency of 3 and another string with a frequency of 1. Basically, if there are let's say L strings, there should be L minus 1 and 1, and the difference between S1 and S2, let's call them S1 and S2, should just be a single character, right? The shortest factor that satisfies it is the answer to the problem, right? Let's take a sample quickly. So what is the answer to this? The answer to this is 3. So if you see 3, let's take 6 first. So ACB, ACB, right? ACB, BCB, ACB. Okay, so we have to start with the smallest, right? So you have to start with 1, of course, right? But in 1 you see there are multiple occurrences, so this is not satisfied, right? L minus 1 and 1, so you'll just skip. You can even take 2. So ACBB, you again see there are 2 dissimilar characters, right? And there are multiple groups forming, so you have to again skip. With 3 you will see that you are forming ACB how many times? 3 times, and you are forming BCB once, right? And the difference between this is just 1 character, right? So that's all. That is the answer, right? So let's see how to code it. Read the string, and for let's find the factors, right? Actually we can just do everything on the fly, right? But finding factors will take the square root of n square root of n is going to be for 200,000 square root is going to be 1e7, might fail time. Right, so either we can do C even 5 all the factors already, right? If I have C, I'll just do that. It's prime C actually. Let's just do root n first. Let's see if that passes, right? So we have to start with 1 as well, right? And we have to go until square root of the factor, square root of the number to find out the factors. So if number length modulo I is 0, basically it's a factor, the length is a factor. Now you do the okay, now again you have to choose between using map or not. So using a map, instead of using a map, I think we can apply something else which is smarter. So for let's say we have 4 groups of string with every length is length of 3. So if you can see all the respective positions should be equal, right? Except one position won't be equal everywhere, right? So you have to take care of 2 things. Out of 3 positions, 2 positions will exactly be equal, right? And one won't be equal only at a single place. Meaning for ABC you see A equal, right? ACB, sorry. So, sorry, this was B actually. So there's just one difference. There's no two B's, remember, just single B, and all other respective positions are same. ACB, BCB, right? So let's have int group max count, right? Group dissimilarity count, right? Basically number of groups that are not similar, and maximum group dissimilarity count, basically the maximum number of elements that are not equal. Right. So for every group, so what you'll do, you'll run the entire loop for length, right? So the length now is n by k, n by I basically, right? So for you start with j, right? So actually I'll expand the for loop so that it's easier to understand. For int j is 0, j is less than n of course, and j plus equals to length, right? So we are jumping lengths. Now if j is 0, actually what we have to do is we have to jump over all the groups, right? So we'll do, let's say starting point is 0, starting point is less than length, starting point plus plus. Basically you have to check all the groups, right? So you start with 0, you jump length, you start with 1, you jump lengths, right? So you have to solve it like that. Let's see. Okay, now this is a single group, right? So for a single group we'll maintain two variables, right? One will be okay, which is if everything is same, right? So if everything is same, we'll just do okay and is equals to s of string of j is equal to string of starting point. Okay, whatever the starting point was, right? Now in the end, if they are not similar, you have to increment group dissimilarity count by this. Okay, so number of groups that are not similar, right? What are groups? One jump is a single group, right? Now if they are not similar, right? If s of j is not equal to s of p, right? You'll maintain another variable that's called int dissimilar count, right? You'll do dissimilar count plus plus, right? This is s of sp. Now understand that the first character might also be different, so it can be a, it can be something like a, a, b, b, b. In this case you are getting dissimilar count of 3, but you'll also get, you cannot just write it as 3 can be correct, because even this is a dissimilar count of 3, right? So to handle that you have to take unique elements, right? So you can just do set dot insert a of s of j, right? Now at any point if s of j, uh, if size of the set is greater than 2, right? You can just have two different stuffs, right? You cannot have more than that, right? So you can just mark it as invalid, right? And to mark it as invalid, instead of making a new flag, let's just say maximum you made group dissimilarity count GDC equal to 2. I'll explain that why we did that. Right, now else if size of set is 1, right? Actually we could have skipped a lot of these. if size of set is 1, right, basically everything is fine. Or if size of set is 2, you can say okay is not okay. You can just do GDC plus plus actually, right, and here we won't need the okay flag, right. Actually I'll explain it because it's getting a bit spaghetti, right. So what is happening is if the size of set is greater than 2, right, if you have more than one similar elements, you can never make them equal, right. So in the end what I'm going to do is, if group dissimilarity count is just one group is dissimilar, right, if just one group is dissimilar and the maximum dissimilarity that you have within a group is 1, right, m maximum dissimilarity is also 1, right, or group like you can also have none of the everything matching, right. If this is true, you can actually just print this value. Print what? Print the length, or you can just print length, right. Actually there should exist a -1 case as well, if I'm not wrong. For each length of the shortest at most one symbol. Actually what will happen is when you are configuring it for the last group, right, or let's say it's ABCD, so we'll just print 4, right, and here we have to work on finding factors. We'll just make a factor, and if n modulo I double equal to 0, factor dot pushback I, if n by I is not equal to I, after pushback n by I, right. You can sort all the factors, right, then you can take each factor one by one, each xn factor, right. So instead of I here, you can just use x, right. Now if size of set is greater than 2, you can just set g equal to 2. This will always negate this, right, and immediately terminate this length, right. It will immediately terminate this length, it will discard this length, right. Now if it is equal to 2, right, if it is equal to 2, you will increment it once. Now also remember that no two groups should have dissimilarities, right. Now that's fine. Now the problem is how many dissimilarities are there, right. So this, right, so actually instead of having mgdc as well, you can just use the same flag, right, gdc, right. Now remember that you should not have more than 2 characters not matching, right. Now what happens that if size of set, what are legal conditions? If size of set is 2 and dissimilarity count is length -1, that works. Why? Because this is the case for B A A A, right, it's fine. Else if DSC is equals to 1, this is also fine, right. What is that case? That case is A B B B, right. Now remember that this only holds when size of set is 2, right. In all other cases you can just set GDC to 2, saying that this is illegal, right. What will happen when this is actually the length is actually the entire string, right. So if the length is actually required is the entire string, so what will happen is this is not going to increment, this is already always equal, right, and size of set is always 1, right. So this will not increment as well, Okay. Well, let's see if the factors are coming up correctly first. 1 to 4, 1, 3. For 12, okay, we are having multiple values pushed. Right, so I think we can just. I don't want to use a set because it will increase the time complexity. Right, 1, 2, 3, 4, 6, 12 looks fine. 1 to 4, it looks fine. Right, now the problem is why it is not printing. Right, so let's take 12. Right, and for every particular x, let's print the GDC value. So for 1 it's 2, for everything it's coming as 2, for 3 it's coming 3. Right, so for 3 it should not be 3. So if factor is 3, let's print the set once. So it's A, B, A, 9798, 99. Okay, it's the other way around, right? So if length, okay, length is the length, right? Okay, yeah, so it's not x equals to 3, it's length equal to 3. X is the number of partitions. Okay, so that is where we are going wrong. Right, so we have to use x as the length. Right, instead of here it's x. So for 3, if you're saying that you are getting 97, 98 for first, then 99 and 98. So that means, okay, it's matching. Right, let's remove the set now. We're getting some value back. We are not printing anything. So for 3, it's printing 2. It should not be printing. Size of set is not greater than 2. If size of set is double equal to 2, you just do a plus plus. Okay, so that is actually fine with 3 because we're just having two ones, right? So 1, 2, 2. Else, okay, actually if dissimilarity count is 0, then also you continue, right? Else you do this. Now I don't write if else like this, but just to explain all the cases I've written it like this. Right, so yeah, this is printing 3 actually, this is fine. Yeah, this actually passes. Let's hope it passes here as well. C++ 20. Let's run it first. Check the leaderboard. Has anyone solved it? Okay, we're fine with this. Okay, we're missing some cases. Okay, I think I have the most number of penalties out of everyone. So actually we are not running out of time, which is fine. So I think I can write a more time consuming approach, right? So okay, so every time I get a wrong answer and I see my that logic is pretty complicated, I try to write an easier one, right? So what I am going to do is I am going to generate strings now, right? So I'll map a string with int, right? And for I starting with 0, right? Now remember that every length is x, so you have to pick x lengths at once into a single string, right? So how do you implement that? So for I 0, this is the starting point, so we can just take it as starting point from 0 to so starting point is 0 and it goes up till n and it gets incremented by x, right? So basically we start at 0 1, then we start at x again, right? Now it no actually, okay, let's see. So if we have 12 and we are taking 6, so length of 6 at once, right? So we are taking 0 1 2 3 4 5, so the starting point is once 0, next it should be 6, right? And we are taking 6 elements here, right? I think that will be handled itself, right? So x is incrementing. Now for x you can construct a string, right? So let's call it string x. So and let's just initialize it. So s plus equals to I think we should take something else, temporary string. Ts plus equals to s of I, right? Or yeah, s of I, not I actually, starting point plus I, right? And we take map of s plus plus, a temporary string, right? And to have a better idea, let's just print it here. Something's wrong. Yeah. So if you're taking a single element, A is thrice, B is times. Now if it see here, it's perfectly sitting right. So okay, so for the first thing that you should be having, that if size of map is double equal to 1, you can just return the size, right? Or you can just return x, right? Else if size of map is equals to 2, right? Now this is a case where you have to analyze further, right? Because uh, yeah, so okay, so we find the two strings, right? Also, if even if the size is 2, it should be spread like L minus 1 and 1, right? So we take max and min, right? Max let's take as 0, min will take as min plus 1, right? And for every element in map, max is equals to maximum of max and its frequency, min is equals to minimum of minimum and its frequency, right? And you remember how it should be spread. So if max is equals to, so basically max plus min should be equal to the number of groups, right? So max plus min should be equal to n by x, where min is 1, right? This is the condition where it satisfies, right? Now if that happens, now you find the strings which have this max and min frequency, right? Or you can just take two strings a and b, right? So now how you extract those strings from map is, if size of a is 0, right? A is empty, so you can just write it as that. Else if x dot ff is not equal to a, this is when a has been assigned, you assign that to b, right? Now you find the Hamming distance between A and B, right? So you take it as C, and for uh, can we use I? Yeah, for S dot length or A dot length, right? You find the distance. So C plus equals to A of I is not equal to B of I. Now if Hamming distance is 1, if C is equals to 1, you can just return the length that you can pick here, right? Should work. 3, right? We remove the map from here. So this passes, but this takes more time, right? And I'm very unsure if this will pass the time limits, right? Because you're reading string multiple times and you're storing it, you're mapping it, you're hashing it. One thing you can do is you can just make it unordered. Let's run it first. Right, passed. Let's see if it passes here. You have to print the minimum. Right, so we started with the minimum. Yeah, it passed everything. Okay, we could have done a lot better, I think. At least in this. Right, so I think I'll upload this video, right? If you have doubts, you can ask it in the comments, right? And apart from that, okay, you can just use the comments to ask me doubts. Thank you.